We're using a GPR, Gaussian process regression, model with a Matern kernel. Think of the kernel as the function that defines how similar data points are. The Matern kernel is a specific type, known for its flexibility in modeling different levels of smoothness. I'm testing your knowledge of the Matern kernel's NU parameter. This parameter controls how smooth or rough the model's predictions are. It's like tuning a dial. You can adjust smoothness with it. A higher NU value results in smoother predictions, which means the curve will be less wiggly. If you set NU to 0.5, the Matern kernel becomes equivalent to the Ornstein-Uhlenbeck kernel. This is a special case within the broader Matern family. I'm checking if you know the possible values for NU. This isn't always an integer, it can be any positive real number. While a larger NU allows for modeling more complex functions, it doesn't automatically guarantee effectiveness. High complexity increases the chances of overfitting, especially with limited data or noise. See, NU, which represents the smoothness parameter in the Matern kernel. It defines how wiggly or smooth the resulting prediction curves will be. Think of it like this. A low NU value gives you a really bumpy, unpredictable curve. A high NU value creates a smooth and predictable one. The Matern kernel lets you adjust this parameter to fine-tune the model to the data. This is a multiple-choice quiz testing your knowledge of the Matern kernel, a tool we use for Gaussian process regression, GPR. You'll examine statements about the Matern kernel's NU parameter and determine which are factually correct. This tests your comprehension of the parameter's effect. It's like a mini-exam on a key concept. Increasing NU's value results in smoother predictions. Imagine a roller coaster. A lower NU means lots of sharp turns and drops. Rough. While a higher NU means a much smoother ride. Setting NU to 0.5 is a special case that makes the Matern kernel become the Ornstein-Uhlenbeck kernel, which has particular properties. A larger NU allows for representing more complex relationships. However, beware, if you have limited data or noisy data, a very large NU might lead to overfitting. NU doesn't have to be a whole number, it can be any positive number. That gives you a lot of flexibility when tuning your model. I'm using Sklearn's Gaussian process regression, a powerful machine learning technique that uses Gaussian processes to model relationships between data points. It's perfect for situations where you want to predict continuous values and need to account for uncertainty in your predictions. Think of it as drawing a smooth curve through your data points while acknowledging that future data points might vary a little. I'm testing your knowledge of the Matern kernel, a specific type of kernel function commonly used in Gaussian process regression. A kernel function defines how similar data points are, influencing the shape of the predicted curve. The Matern kernel has a parameter called NU, which we'll explore. The Matern kernel is a family of covariance functions, and is the crucial parameter that controls the smoothness of the resulting function. We'll delve into how different values of impact model behavior. As you increase, the predictions become increasingly smooth. Imagine drawing a curve through your data points. A higher makes the curve smoother. It's like using a very fine brush. When equals 0.5, the Matern kernel becomes identical to the Ornstein-Uhlenbeck kernel, another commonly used kernel in machine learning. This is a specific case within the broader Matern family. Nope, that's not quite right. Can actually take on any positive real number value, not just integers. Larger does mean the model can capture more complex relationships in the data. However, it also increases the risk of overfitting, especially if you have limited data or noisy data. So, it's a trade-off. I want you to pick all the statements that accurately describe the Matern kernel parameter. Think carefully, not all statements are correct. The Matern kernel is a popular choice for Gaussian process regression. It's characterized by a parameter, NU, that controls the smoothness of the resulting function. Think of NU as a dial that regulates how wiggly or smooth the prediction curve will be. This is a multiple-choice question about the Matern kernel and its NU parameter. I'll guide you through each option. This question tests your knowledge of the Matern kernel's properties, focusing on the role of the NU parameter in shaping the model's predictions. You need to carefully consider each statement. This statement is correct. As you increase NU, you'll find your predictions become smoother. Imagine smoothing a rough sketch. The higher the NU, the smoother the final drawing. This is also true. The Matern kernel is a family of kernels, and when nu is set to 0.5, it becomes the Ornstein-Uhlenbeck kernel, a specific type within that family. This is incorrect. The nu parameter can actually take on any positive real value. It doesn't have to be a whole number. You could use nu equals 1.5, 2.7, or any other positive number. While it's true that a larger nu allows for modeling more complex functions, the word, effectively, is key. A larger nu increases risk of overfitting, especially with limited or noisy data. You could capture noise instead of the real signal. Therefore, this statement isn't entirely correct. This is the main question. I'll evaluate each statement provided to determine its validity based on my knowledge of the Matern kernel in Gaussian process regression. Let's analyze each one carefully. This statement is correct. The Matern kernel is a family of functions, and when its smoothness parameter, nu, is set to 0.5, it becomes equivalent to the Ornstein-Uhlenbeck kernel. It's a specific case within the broader Matern family. I agree that this statement is true. A higher nu value in the Matern kernel results in smoother prediction curves. This is because nu controls the smoothness of the function it models. Think of it like drawing a curve. A higher nu value allows for a smoother, more continuous line. This statement is partially true, but it needs more clarification. While it's true that a larger nu does allow the model to capture more complex functions, effectiveness depends on the data and the potential for overfitting. If I have limited data or noisy data, a complex model, high nu, might overfit and not generalize well to new data. This statement is false. Nu can be any positive real number, not just an integer. The Matern kernel's flexibility comes from this parameter's continuous range. This is the title describing the topic of exploring the nu parameter in the Matern kernel, a specific type of function used in modeling relationships between variables. I see this statement as correct. A larger nu value in the Matern kernel means the resulting function will be smoother, meaning fewer sudden changes. Think of it like drawing a curve. A higher nu makes the curve smoother. I disagree with this statement. The nu parameter can actually be any positive real number, not just a whole number. It could be 0.5, 2.7, or any other positive value. I think this statement is partially true but misleading. Yes, a larger nu allows for the model to capture more complex functions, however, it doesn't guarantee effective modeling. Overfitting is a real risk with a large nu, especially if you don't have enough data or if the data is noisy. This is absolutely correct. Setting nu to 0.5 in the Matern kernel gives you the Ornstein-Uhlenbeck kernel. They are closely related. This is the central question for this quiz about the Matern kernel and its parameter nu in the Gaussian process regression. We have to carefully examine the options given and assess each one individually. The options test our understanding of the relationship between nu, smoothness, and model complexity. I see this parameter, nu, controls how smooth or wiggly the resulting curve from the Matern kernel will be. Think of it like adjusting the tension on a rubber band. A higher nu means a tighter, smoother curve, while a lower nu makes it more flexible and potentially bumpy. This directly impacts how well the model fits the data. It's all about finding that sweet spot. The Matern kernel is actually a whole family of functions, each member distinguished by its nu parameter. It's like having a toolbox full of different curve-fitting tools. You pick the best tool, the best nu value for the job, based on the data you have and how smooth of a model you need. I see this question wants you to test your knowledge on how the Matern kernel works, specifically the role of its parameter. It's a multiple-choice style question and you have to pick correct options based on your understanding. Let's see what you know. I see this refers to the core of the problem, Gaussian process regression with the Matern kernel. We use the Matern kernel, which is defined by its parameter alpha, nu. The question tests your understanding of how this parameter affects the model's output. I agree with this statement. A larger nu value makes the function smoother. Think of it like drawing a line. A smaller nu will create a wiggly line, while a larger one will create a much smoother one. I agree with this too. There's a special relationship between certain values of nu and other kernel functions. When nu equals 0.5, the Matern kernel becomes the Ornstein-Uhlenbeck kernel. It's like a specific case within the broader Matern family. I disagree here. Nu can be any positive number, not just integers. I partially agree. A larger new does allow for more complex functions. But, I want to caution that it also increases the risk of overfitting. It's like having more paint colors, but you may still make a messy painting if not careful.